Welcome back to All This Math. This is Professor Parker. Please make sure you are subscribed to the channel. Go ahead and like the video. Go ahead and hit the button. Also, drop a comment if you're so inclined. Also, if you have questions about anything that I end up explaining that's not real clear for you or real clear to you, please put your question in the comments. Also, share this video with somebody, right? This is a very important geometry topic. Share it with somebody. Don't be selfish. All right. Now, what are we doing today? Today, we're doing a problem that involves the secant-tangent theorem. The secant-tangent theorem. All right. Now, what does the secant-tangent theorem say? Now, geometry got a whole bunch of theorems and postulates and corollaries and laws and all that. The secant-tangent theorem is just another one, right? It deals with circles. All right. So you see, we have a circle here, right? And we have a tangent. A tangent is a line that touches a circle in exactly one point and one point only. That's what a tangent is. See how this line goes from point R to point P and then on? Actually, it's not a line. It's a ray. Technically, it's a ray because a ray starts from a point and goes on forever in one direction. And this is another ray. Starts at a point and goes on in one direction forever, right? So technically, this is a ray. So make sure we know our geometry vocabulary. Make sure you know the difference between a ray and a line. A line goes on forever in both directions. A ray starts at an endpoint and goes on forever in one direction. That's the difference between a ray and a line. Make sure you know that. All right. So now, but this ray, it don't look like it, but it's supposed to just touch this circle in one point exactly, right here at point P. All right. Now, a secant is a ray or a line segment that touches a circle in 2 points, exactly 2 points. So you see how this starts at point R, it goes on, it hits the circle at point L, boom, keeps going, hits the circle again at point C, boom. You know what I'm saying? So that's a secant. All right. So you have a secant-tangent theorem that enables you to figure out information about the lengths of the tangent and the secant. So what does the secant-tangent theorem says? It says this. It says that the length from an endpoint. So if you got a tangent and a secant that go from an endpoint outside the circle, right? The length from the endpoint out here to the tangent point squared, raised to the second power or multiplied by itself, that length. So here to here, here to here, right? Squared is equal to or is the same as, follow me, the length of the secant from the outside endpoint to this point right here. So from here to here, right? Times the outside part of the secant. So this is the inside part of the secant because it's inside the circle. This is the outside part of the secant because it's outside the circle. All right. Now what does that say? This part squared is equal to the whole length of the secant times the outside part of the secant. I'll say it again. The secant-tangent theorem says this. The length of the tangent from the outside point to this point squared, raised to the second power, not the third power, fourth power, raised to the second power, is equal to the secant from this point to that point times the outside part of the secant. Now, let's set up our equation. I think I'm going to use purple for the work. Got everything written in blue, but I'm going to use purple for my work. All right, so that means PR squared. Actually, no, I'm going to do R. Yeah, PR. Now, I was strategic in picking these letters. PR are the initials of Paul Robeson. Paul Robeson. If you're not familiar with Paul Robeson, please go learn about Paul Robeson. He wrote a short autobiography called Here I Stand, and several biographies have been written about him. As a matter of fact, I think his wife is Landa Robeson, who had a background in chemistry and also did work in anthropology and history herself. I think she wrote a book about Paul Robeson. That's dope. That's kind of like Du Bois's second wife, Shirley Graham Du Bois, who was a historian. She wrote a book about him. She wrote a biography about him. You know what I'm saying? That's kind of fly. Your wife read a whole book about you. And it's not no like, no smut book or nothing like that. It's not no tell-all like trying to throw somebody under the bus type book. A historical account. You know what I mean? But anyway, PR stands for Paul Robeson. All right? So PR, Paul Robeson. All right? Squared is equal to the whole secant, CLR. Those initials should be familiar to some of us watching this. CLR James. CLR James, a Trinidadian, a Pan-Africanist. All right. wrote The Black Jacobins, a book about the Haitian Revolution. Something else we should know about the Haitian Revolution lasted from 1791 to 1804. Our African brothers down in Haiti, which was then called Saint Domingue, was a French colony. They defeated the French, beat Napoleon. They beat Napoleon, right? I know in school and history and world history, we learn about Napoleon, oh, this great leader and all that. Nah, our people beat Napoleon, and they beat the British, and they beat the Spanish. All right, keep that in mind. We have won sometimes. They just don't want us to know about that. All right. So C.L.R. James wrote a book, among many other books. He also wrote a book called The History of Pan-African Revolt, which is a short book about different like slave rebellions and black radicalism, right, throughout history. All right, in the Western Hemisphere. So you got CLR. All right, so it's going to be CL plus LR though. So it's going to be CL plus LR, right? The inside part of the secant plus the outside part of the secant. The inside part is from point C to point L, so that's CL. The outside part of the secant is from point L to point R, right? Then you multiply that by the outside part. Multiply that by LR. All right. This is the secant-tangent theorem. All right. So the tangent part is squared, and the secant part is the whole secant times the outside part of the secant. Now, let's replace our segments with our numerical values and our expressions. So PR is 5, right? This is our information. Oh, and by the way, I should have said this in the beginning. Our goal is to solve for X. Those are our instructions. Solve for X, meaning find out the numerical value of X based on this information and using the secant-tangent theorem. So PR is 5. So we're going to replace PR with 5. That's going to be 5 squared. Then we got CL. What's CL? 2X plus 5. That's an algebraic expression. So we got 2X plus 5 plus, what's LR? 3 plus 3 times, what's LR again? 3. Boom. All right. So now, what do we do? What do we do? In these parentheses, I would combine like terms. So I would have 2X plus 8. Combine like terms. Then over here, 5 squared. 5 squared is not 10. All right. Don't play with me. Don't say 5 squared is 10. All right. 5 squared is 25. Because 5 to the second power means 5 times 5. This is slang. I say this all the time. 5 to the second power is like slang. It's a short way of saying 5 times 5. But don't nobody got time for all that to say 5 times 5. So we're just gonna say 5 to the second power, or 5 squared. Right? 2 5s. That's why we got the 5. That's why we got the 2 there, because it means in a multiplication sentence, you would have 5 written how many times? Twice. That's what the exponent 2 means. All right. So we got 5 squared, so that's 25. 25 is equal to this over here, this quantity, 2x plus 8 times 3. Let's hit it with the distributive property, meaning we're going to distribute this 3 to everything inside the parentheses. Do not multiply this 3 by 25. This 25 don't got nothing to do with this over here. All right. 3 times 8, 3 times 2x. So that's going to be 6x plus 24 on the right-hand side. 6x plus 24. Then you got 25 on the left. We solving for x. We're trying to isolate x by itself. We try to isolate x by itself. So what we got to do, we got to get rid of 2 things. Eliminate this 24 and eliminate this 6. Eliminate the 24, eliminate the 6. Does it matter which we do first? No, it don't. But what I like to do, because that's just me, I like to get rid of the constant first. This 24 is a constant by itself. This 6 is a coefficient. I'm going to get rid of the coefficient second. So I'm going to do minus 24 on the right side, minus 24 on the left side. Again, if you got any questions about anything I've been doing, please put that in the comments. Put that in the comments. All right. So 24 minus 24 is going to be 0. 25 minus 24 is going to be 1 is equal to 6x. Oh, this is messy. Now, what a lot of people are going to do is they're going to get to this part of the problem and think they did something wrong automatically. Why? Because most of the time in school, when we do algebra, we end up with nice, neat integers for our answers. You know, integers like 3 and 5 and 8 and 22 and all that make you feel all good inside. You know what I'm saying? Right? But it ain't always like that. Life ain't always like that. You know what I'm saying? Sometimes your answer going to be a fraction. Like right now, the answer about to be a fraction, and that's okay. That happens, right? You know it's going to be a fraction. You can anticipate that the answer is going to be a fraction. Why? Because we got to divide by 6 to isolate the x. Because 6 divided by 6 gives us 1, and that gives us 1x. And again, slang, 1x is the same thing as x. Don't nobody need to say 1x. Ain't nobody doing that. 1x, we don't say that. We just say x. All right, because 1x and x are equivalent. X is a more efficient way of expressing 1x. So we divide by 6 on the right side, we divide by 6 on the left side. We got 1/6, right? It's a fraction. It's a fraction. It happens. Sometimes your answer will be a fraction. Sometimes your answer will be a decimal. Get used to it. All right. So x 1/6 is equal to x. So that means that, let me write it up here. X equals 1/6. So we were tasked with solving for x, and we did that. X is equal to 1/6. All right. And that's the secant-tangent theorem with Paul Robeson and C.L.R. James, Trinidadian historian, social scientist, writer, Pan-Africanist. Paul Robeson was a Pan-Africanist too. All right. He was from Jersey. You know what I'm saying? But definitely do your research on CLR James, do your research on the Haitian Revolution, do your research on Paul Robeson and a lot of the people that they ran with back in the 20th century. All right. And as I said, make sure you are subscribed to the All This Math YouTube channel. Make sure you drop a comment down below or drop a question down below if you got a question about anything I did. All right. Also, like the video. I'm asking nicely. Please like the video. All right. Also, share this video with some people. Share it with as many people as possible. All right. See y'all later. Peace.